Today we're moving into a new topic a little bit in the sense that it's the inverse. So we had, We had natural logarithmic functions with 5.1. Then 5.2 was natural logarithmic functions, the integral. Then 5.3 was inverses, and now we're moving on to 5.4, which is the inverse of the natural logarithmic function, which is exponential functions. Oh, yeah. So, I know, it's so exciting. It says, definition of the natural logarithmic function is, or natural exponential function is y equals e to the x. So that's the inverse of y equals ln of x. So if you were going to find the inverse of the function, remember, in order to find the inverse, you just switch x and y. So I could switch x equals e to the y, and then solve for y. How would I solve for y in that equation?
Take the natural log.
Take the natural log of both sides. So ln of x equals ln of e to the y. And then this e to the y cancels. So I have ln of x equals y. So that's the proof that these are inverses of each other. The exponential function is the inverse of the natural logarithmic function. If we look at the graph, if you guys have some different colors, you might want to use some different colors. So if we look at the graph of the logarithmic function, so here's the graph of the logarithmic function. It looks like this, and it follows that asymptote all the way down. And so the exponential function is the inverse of that one, so it looks like this. And follows it up like this. And then just to make sure that these are actually inverses of each other, if you look at the reflection across the line y equals x, it looks something like that. So you can see that these are actually inverses of each other. I promise. Alright, so these are inverses of each other. You can see from the picture as well as from the actual algebraic part of it. The properties of natural exponential functions, there are 4 properties, and they're very similar to the logarithmic ones. You've probably learned them already. The domain of the natural the natural exponential function is from negative infinity to infinity. So this is the purple one that we just drew. What's the range of that natural exponential function?
Everything greater than 0.
Good. So from 0 to infinity is the range of the natural exponential function. So from 0 to infinity. The exponential function is continuous on its entire domain. It's increasing on its entire domain, which means that f prime is what?
Greater than 0.
Greater than 0, positive. And it's also 1 to 1. This is my symbol for 1 to 1, 1-1. How do you know if something's 1 to 1 or not?
One alpha for every input.
Good. So it passes the vertical and the horizontal line test. Passes both of them.
I'm ready for math.
Number 3, it is concave up for all values of x. Do you guys know what this symbol is? Have I showed you guys that before? The upside down A?
All values.
For all. That means for all. So if you guys ever get into higher math classes and you see that, that's for all. So concave up for all values of x. What does that mean about the second derivative, f double prime?
It means that it's always increasing.
It's always increasing, which means it's always,
0.
and not necessarily always increasing, but always positive, so greater than 0. And last but not least, the limit as x approaches positive infinity of e to the x. What do you notice as you go towards positive infinity on this purple graph? As it goes towards positive infinity, what's the limit?
Infinity.
Positive infinity, good. And what about the limit as it goes towards negative infinity?
0.
Good. The limit as x approaches negative infinity of e to the x. And you can see it as it goes towards here. As it goes towards negative infinity, it would get closer and closer to 0. Alright, and then the derivative down here at the bottom, the derivative of e to the u equals u prime e to the u, where u is a function of x. So I think I told you guys this yesterday, but the derivative of e to the u is e to the u, but you have to use the chain rule. So if u is not just a simple x, obviously you have to use the derivative using the chain rule. So you take the derivative of what's inside and multiply it times the derivative of the outside. Alright. Let's do some examples. So on this first one over here, y equals e to the 5x. What's the inside function?
E.
That is actually the outside function. 5x is the inside function. So the derivative of e to the 5x, y prime, oops, let me go back really quick. Y prime equals, good, the derivative of e to anything is e to the same thing. So the derivative of e to the 5x is e to the 5x times 5, which is the derivative of the inside function. So that's the chain rule. The derivative of the outside times the derivative of the inside. So you can rewrite this if you want as 5e to the 5x. Now obviously the unfortunate part about this is that that is such an easy derivative that the problems don't stay easy for too long. Not that they're getting super hard, it's just that they're gonna start to look harder even though they're not really that hard.
Like the next one?
Like this one. It's not a super hard problem. We have two options. We can either bring the bottom up to the top with an exponent of -1 and do the chain rule, or we can leave it as it is and do the quotient rule. Which one would you guys rather do? Okay, so let's rewrite this as y equals 2 times e to the x plus e to the negative x to the -1. Now the 2 is just a constant out front, so it comes along for the ride. There's nothing that it bothers. So when I take the derivative, y prime equals 2 times, what's the outside function?
-1 or something to negative.
Something to the -1 power. Good. So if I kind of block this out really quick until we get back to it, if I block this out really quick, that would be something to the -1 power. What is the derivative of something to the -1 power? -1 something to the -2 power. Good. So this would be -1, so times -1 times something, e to the x plus e to the x to the -2 power.
Oh man, I got the inside too?
Times the inside, but the inside, even though it looks complicated, it's super easy. The first one, what's the derivative of e to the x? E to the x. I'm sorry I'm writing this on 2 lines, it should be 1, I just don't have enough room. So this should all be a same continuation of the line. So the derivative of e to the x is e to the x. What's the derivative of e to the x? E to the x times? -1. Good. E to the x times -1. So if I can simplify this a little bit, I have -2, and then I'm going to push this to the bottom since it has a negative exponent. So -2 times e to the x minus e to the x divided by what I push to the bottom, which is e to the x plus e to the x to the 2nd power.
But wouldn't that be a positive 2? Because there's 2 negative ones.
The 2 at the very beginning?
No, never mind. Because
Yeah, the second negative one's only to that one term. Alright, good. So that would be the final answer for that one. You could have also done that using the quotient rule if you wanted to, and something that might be easier. It was about the same amount of steps, so it's not like this one's that much easier than the quotient rule. A lot of you guys don't like the quotient rule, but sometimes it does save you time to use it. So like in this one, for example, the derivative of the top is 0, so it would have canceled out the entire first term automatically. Alright, good. Let's look at number 3. On number 3, you have to use the product rule. So I'm going to let you guys try number 3 on your own first, but use the product rule on number 3. Alright, so with the product rule, I know that some of you guys continue to use the u and the v. If that helps you do it, what I'm going to say is as we get closer and closer to the AP test, I really urge you to try to do it first without the u and the v, and then if you get stuck or you think you messed up, maybe go back to the u and the v. But the u and the v will definitely slow you down if you're trying to use that on the AP test, so please make sure that you're trying to do it in your head, and just repeat it to yourself in your head rather than writing it down on paper. So the product rule is the derivative of the first, which is 2x, times the second, which is e to the x, plus the first, which is x squared, times the derivative of the second. What's the derivative of e to the x?
Negative e to the negative.
Negative e to the x. Good. So on this one I have 2x e to the x minus x squared e to the x. Now technically you could leave your answer like that, but because they both have something in common, a lot of times on AP tests or multiple choice questions, they'll factor out what they have in common. So what do they both have? They have an x and e to the negative x. So this would become 2. The x and the e to the negative x would get pulled out, minus x. And then just one more simplification. They don't like negative exponents. So I'm going to write x times 2 minus x. And I'm going to move that e to the negative x piece to the bottom so that it doesn't have a negative exponent anymore. Now, technically, again, like I said, this answer here could have been correct. It's not necessarily wrong for any purposes. But on multiple choice tests, you'd much more likely see it written as the last answer than that first one. On free response questions, leave it however you want. As long as you actually did what they're asking you to do, no simplification is required. All right, for number 4, y equals e to the 4th. What's the derivative of y equals e to the 4th? I hear e to the 4th.
Times 4.
Times 4?
Times 1. Yeah, because what's the derivative? Yeah, 0.
Times 0. Good. E to the 4th times 0, which is just 0. That's because this is a constant. E to the 4th is actually a number. If you plug in e to the power of 4 in your calculator, you're going to get a number. So this is a constant function. So the derivative should be 0. Yeah, it's not too bad. All right, let's look at 5. What is the outside function on number 5? ln of something. What's the derivative of ln of something? 1 over something. Good. So this would be y prime equals 1 over something times the derivative of something. What's the derivative of 1 plus e to the power of 2x? Good. E to the power of 2x times 2, which is 2e to the 2x. So if I want to rewrite this one more time, I get 2e to the 2x divided by 1 plus e to the 2x. No, it's not. Like I said, the problems look a lot harder than they are because the derivative of e to the x is so easy. All right, I'm going to let you guys try number 6. I'll give you a hint on that first term. You have to use the product rule because it's a function of x times a function of x. So go ahead and try number 6 on your own really quick. So for the first one, you have to use the product rule. So y prime equals, the derivative of the first is 1 times the second, plus the first times the derivative of the second. Well, the derivative of e to the x is just e to the x, and the derivative of x is 1, so that's not going to change. Minus the derivative of e to the x, which is e to the x. So e to the x cancels with e to the x, and you're left with x e to the x.
No wonder there's like 70 problems.
Yeah, they're not going to take you that long. All right, good. Let's look at number 7. So this one says, in the following examples, use implicit differentiation to find dy dx. I know you guys are not huge fans of implicit differentiation, but I actually appreciate, one of the things I appreciate about calculus the most is that in calculus, they keep spiraling everything back in again. So a lot of things are, like limits maybe is the only thing that we don't really talk about that much anymore. We talk about derivatives all the time. We talk about, implicit differentiation. That was something we learned months ago, and they keep bringing it back in, which maybe is a grown thing because you don't really like it that much, but at least when we come to review for the AP test, you won't have to really reach way back into like November's memory. You'll have it fresh because we use it all the time. So even though it maybe is something you don't like to do that much, it actually helps you out the fact that we revisit it so much because you won't have as much relearning to do when we get closer to the AP test. So for the first one, remember that implicit differentiation says it's difficult, or too difficult I should say, to solve for y by itself in an equation. So instead what we're going to do is we're going to use implicit differentiation to find the derivative. So anything that has a y in it, you have to remember that the derivative of y is y prime. So for the first one, what rule are we going to have to use for that one? Product rule, because it's a function of x times a function of x. Remember that y is a function of x. So the product rule. The derivative of the first, what's the derivative of x? 1 times the second, so times e to the y, plus the first, which is x, times the derivative of the second. What's the derivative of e to the y?
E to the y.
Good. E to the y, y prime. The second one, negative 10x. What's the derivative of negative 10x?
Negative 10.
Negative 10. And what's the derivative of 3y?
3y.
3y prime. Good. Because the derivative of 3y is just 3, and then the derivative of y is y prime.
Oh, and then you gotta put it over the fact out the y prime.
Good. Here are the two terms that have a y prime. So I'm going to leave these on the left-hand side of the equation, and I'm going to move everything else to the right-hand side of the equation because my goal is to factor out the y prime to get the y prime by itself. So I'm going to leave these here and move the e to the y and the 10 over to the other side. And I'm going to factor out a y prime at the same time. So this is y prime times x e to the y plus 3 equals 10 minus e to the y. And then last but not least, you can divide by what's being multiplied to y. So y prime would equal 10 minus e to the y divided by x e to the y plus 3. So that one wasn't that bad. It looks difficult, but it's actually not that bad. As long as you can remember with implicit differentiation that you're always going to have that y prime attached to it, then you should be good to go. All right, let's look at number 8. Number 8 maybe is probably the longest problem here. Not necessarily because it's difficult in concepts, but just because it has a lot of steps in terms of reorganizing the answer to make it look the way you want it to look. So let's look at number 8 last but not least. Let me erase all this. You can leave the 10 where it is. We have to take the derivative using implicit differentiation again. So this one here, what's the inside function on that? xy. So the outside function is e to the something. Okay, e to the something. What's the derivative of e to the something? E to the something. So the derivative of this starts off as e to the something times the derivative of that something. What's the derivative of x times y? What rule do we have to use first of all? We have to use the product rule. X is a function of x and y is a function of x. So it's a function of x times a function of x. So the derivative of the first, so in case you guys are wondering, I'm taking the derivative of this piece here, the derivative of xy. The derivative of the first, which is x, would be 1 times the second plus the first, which is x, times the derivative of the second. What's the derivative of the second? Y prime. What's the derivative of the second term? What's the derivative of x squared? 2x. Good. So I just did this piece right here. Good. The last one, the derivative of y squared is 2y times y prime. Good. And the derivative of 10 is 0. So that was really the only calculus part of it. The only thing we have left to do is to distribute the e to the power of xy, leave all of the y prime terms on this side and push everything to the other side, everything else to the other side, factor out the y prime, and then divide by whatever it's being multiplied by. So those are just algebra things, honestly. I know they're tedious, I know they're kind of annoying, but that's all that's left to do. So I'm going to distribute this. You guys can kind of do it on your paper or follow along up here. So I have y e to the xy plus xy prime e to the xy plus 2x minus 2y y prime equals 0. So this is going to stay here, and this is going to stay here, and everything else goes to the other side. And I'm going to factor out that y prime. So just to finish this off, this is technically a right answer. There's nothing wrong with this answer. Y prime is by itself. On a multiple choice question, you might just see the negatives kind of mess with, because a lot of times when you have a lot of negatives in the answer, they try to get rid of as many of them as possible. So technically, if you factored out a negative from the top, you would have 2x plus y e to the xy divided by, if you factored out a negative from the bottom and canceled them, you can just flip these two terms. So if you flip these two terms here, and by factoring out a negative, this term would become positive and this term would become negative, and I can have 2y minus x e to the xy. And that's technically the same answer. Is your answer wrong if you left it like this? Absolutely not. But you do need to recognize that on a multiple choice test, they could write it either way, and those are the same exact thing, and they're equivalent to each other, and you need to be able to recognize that on any test that you'd be given. All right, that's it for today. You guys have a few problems for tonight for homework, but like I said, they don't take too long because obviously, as you can just see, they go pretty quick. So go ahead and work on those, and we'll be good to go.